Today, we're going to pull back the curtain on one of the key technologies that's really, secretly powering this whole AI revolution. It's called a vector database, and it's basically teaching computers to understand information not just by keywords, but by meaning. So let's dive right in.
Okay, so let's start with a super common problem, one I'm sure you've run into. You're searching for things to eat, but you get nothing. Why? Because you didn't type the exact word food. The reason this happens is that traditional databases are incredibly literal. They're just looking for an exact keyword match, not the actual meaning behind your words. So if it's not a perfect match, you get zip.
And this slide just shows you the difference in a nutshell. A traditional search for something like kongkin, or things to eat, fails because it doesn't understand that it means ahan, or food. But a vector search? Oh, it totally gets it. It understands the context, the semantic meaning, and serves up the right result. This is the huge leap we're talking about.
So, how do we get this much smarter search? Well, the answer is the technology right at the heart of this explainer, the vector database. You can honestly think of it as AI's secret weapon. It's what allows all these new applications to finally move beyond simple keywords and start to understand context, kind of like how a person would.
So what even is a vector database? Well, put simply, it's a special kind of library, but it's built to handle a unique type of data called vectors. Now, these aren't just random numbers. They're actually rich numerical fingerprints of really complex stuff. Things like text, images, and even audio. Think of it as a library organized by meaning, not just by words on a page.
So how is this different from a database that you might be more familiar with? Well, a standard database is kind of like a perfectly organized spreadsheet. It's fantastic for finding exact matches, like a customer's ID number. A vector database is a whole different ballgame. It doesn't look for what's identical, it searches for what's closest in meaning. It uses this clever technique called approximate nearest neighbor search, which I know sounds complicated, but it's really just a fancy way of saying it finds the best possible match super quickly, without having to check every single thing. It's built from the ground up for similarity, not just identity.
Okay, this all sounds pretty cool, but how in the world do you actually turn a picture of a cat or a paragraph of text into a big list of numbers?